want to have in mind and in focus as you begin to scale up your analysis services environment or scale it out. We're looking at environments that typically are around the 50 gig up to the terabyte range. Typically, when we're getting up above that 100 to 200 gigabyte environment, that's really where a lot of these things are going to come into play. So if your environment's a little bit smaller than that, don't despair. You're in good shape because your environment doesn't necessarily need to be that big. And as it grows, these are things that you're going to want to consider, maybe not on the scale that we're going to talk about, but these are all good practices for the most part as you're beginning to grow and really see the evolution of your analysis service environment take place. So what do Tier 1 solutions have in common? They have design and query considerations, of course, high concurrent user counts, increased hardware requirements. They're very I/O hungry, and they have some real-time implications. So as you grow and as people get more and more spoiled by the type of cool analysis and things that they're able to do, you're going to be able to deliver hopefully a little bit more real-time data to some very specific pockets of power users and or larger groups of users, and we'll talk about how some of that strategy is going to play out. So some of the things we'll talk about around strategy are also going to include some specifics from some of the SQLCAL case studies and some of the things that they've done with some pretty big implementations and some pretty large companies. So when we talk about design and query considerations, and I'm going to apologize in advance. Most of you guys know I'm a big fan of demo presentations, but demoing changes to a 2 or 3 terabyte cube is not the easiest thing to do over a webinar. So what we're going to talk about today is a lot of really solid recommendations and practice and theory, very, very specific, practical, and if you'll pardon the pun, pragmatic types of items that you can do, not sort of these lofty, high-in-the-sky type of ideas. And then we'll have some definite time for Q&A, and then, of course, you guys always know you can hit me up on Twitter or via email, etc., and I'll give you some great resources to go get some more information here at the end. So when we talk about design and query considerations, simplicity is key. When your cube starts to get very, very large, you have to start removing things that are going to cause it a problem. Things like very large parent-child dimensions. Sometimes those need to be flattened out or gotten rid of. Many-to-many, huge many-to-many relationships can cause problems as well. So your data model may need to change a little bit to accomplish some of those things. You also need to look at your queries and if they're running cell-by-cell versus block mode. For those of you who have questions about cell-by-cell versus block mode, you're going to want to check out the Analysis Services 2008 Performance Guide. It's a white paper that was published on SQLCAL.com. The biggest difference there is the matter of if Analysis Services has to go row by row to analyze your query, or if it can eliminate all the empty tuples in your query and just go get the data. Obviously, we want to try to shoot for as many block mode queries as we want, and there's certain functions like certain uses of if statements and certain types of queries that will purposefully force it out of block mode. So certain time intelligence functions like previous period, parallel period, year-over-year type calculations. Not that those don't have a place in the cube, you just need to be cognizant that they may or may not perform as well as your cube begins to grow rapidly. Data types are very important. I have a little pop quiz in here. I should have put this as a third poll, Rachel, but we've got, there's a question that we do on the Analysis Services Maestro exam, or we used to do. I'm going to have to change it now that we keep talking about it. But it was, which takes up more space, a 1-byte string or an 8-byte numeric? And the answer is the 1-byte string, because a string in Analysis Services actually stores 11 extra bytes for every single string. So it's actually a 12-byte string, not just a 1-byte string. And the reason is because it has to store the string in a separate file under the covers, and without going too far into the internals, data types are very important. So you want to make sure that you have, I mean, it seems obvious, but I see it all over the place. You want to make sure you have integer keys. You want to make sure you use numeric relationships wherever possible, especially in hierarchies and with your attribute relationships. Those are going to be sorted and aggregated so much quicker, and they can be indexed much more efficiently under the covers by Analysis Services for much, much better performance. Plus, if you're using integer keys, when you get to partitioning here in a few minutes, that's going to make your life a lot easier because you can either use the actual keys or you can use hashes of the keys. It's going to give you a lot more flexibility. When we talk about partitioning and locking, We definitely want to talk a lot about partitioning. We're going to talk more about partitioning a little bit later in the presentation. But the big key is really around managing your threading, managing the size of your partitions, and it's really a balance, right? So you want to be able to do, you want to be able to process multiple partitions at one time, maximize the amount of threads that you can make available on the box depending upon your hardware without overrunning it. Excuse me, while at the same time making sure that you're getting good performance. Distinct count performance. We know that distinct count measures, you can only have one per measure group. So those are currently. So those are very, very important things to remember, because you're going to need to make sure that those measure groups are partitioned accordingly, and there's some really cool techniques that we can use to do that. The other thing you need to be careful of is when we're doing lookups and when we're doing queries under the covers or processing, we are issuing locks and hashes against some of those tables. And so obviously the locks are pretty short held, but if you're issuing 1 million of them, just like in an OLTP world, you can tend to run into some issues. Now the nice thing is, a lot of the kinds of things that you're going to run into here are kind of the same thought process that you would run into in a high-end OLTP workload. It's just that the I/O patterns are going to be a little bit different. So we'll talk a lot about some of that here in just a second. So one of the big things is managing multi-user concurrency, right? So when we talk about managing multi-user concurrency, what we're really focused on is making sure that we're not kicking people out every time we have to update the data. So we've got some options for scaling out. We can use analysis services, built-in synchronization. That's typically good up until about the 50 gig to 80 gig mark, depending upon the current number of concurrent users that you're looking at. So if you have 30 gig, but you have 250 concurrent users, there may be some balance in there. We've also got read-only databases. We can do a process in one database, do a detach and attach, or a detach, a robocopy, and an attach. We have lots of different options there, and we can then bring those databases online with a load balancer in front of them and scale out, so that we have multiple databases available, so that our end users can hit a number of different analysis services front ends. The other option that we have, obviously, aside from not having spell check in my PowerPoint today, is sans snapshots and clones, not cones, clones. So what we're talking about there is being able to take the process of database, take that LUN offline or that volume offline on the SAN, snapshot it or clone it. Usually the snapshot is going to be quicker based on like an EMC or HP technology. The snapshot's going to run a little bit quicker. Then you can bring that snapshot online as a separate volume, and these can all be scripted, and then have that available for a read-only database to hit at the front end, which might be much faster than doing a robocopy or doing some sort of detach and attach type of option.